Hi, this is Mr. Frazier, and welcome to Flipping the Classroom, Carnegie style. Okay, and we are going to work on lesson 3.1 and 2. 3.1 is really short, only because it is all information, meaning there's no real new math that we learn. We just learn about some vocab. The first one is linear regression. Okay, and linear regression, as defined by our book, is a relationship between two variables in a data set producing a line of best fit. Okay, so linear regression is basically when we look at a whole bunch of information that does not move at a constant rate. And we've talked about this in class when we've said things that move at a constant rate have a slope, because constant rate means slope, meaning as your input changes, so does your output. Well, a lot of things in real life don't move in a single line. And most of you know that this is called a scatter plot. When you have a whole bunch of information on a graph and it doesn't fall in a line. But they do what they call a line of best fit. Okay? Line of best fit. And this line of best fit is a line where most of the information is around. So let's just take a straight edge so I can kind of do this correctly. A line of best fit looks kind of like that. Okay, it's a line there, and we'll say these are other pieces of information, and you kind of notice it goes through the middle of the data. Okay, and what we would do is we would take 2 points that we made this line on, and we could use accurate points because they would be where the x crosses the y. Okay, and you know it'd be the corner of the box, and we'd be able to find the slope as well as be able to write the equation for the line. Now, the slope would be the subtraction of the 2 points. So let's pretend. Okay, so I'm going to pretend that I was able to put some points here. And this point, let's say, was 15, and this point was 25. And then this over here, this coordinate was 5, and this one over here was, say, 10. Okay, so we'd have our points. The point here would be 5, 10. And you have a point here, which would be 15, 25. Okay, and we'd have to find slope. This is called the line of best fit. Now remember, we're just taking 2 random points from a line that we made up in the middle. This is not an accurate thing. This is called a use of prediction. In other words, we're trying to make a pattern out of something that's not there. And it's just the best fit. It's not the perfect fit. It's just something that looks like it works the best. Okay, that's why it's called best fit. All right, now one of the words you have to be familiar with is range, and hopefully you understand the range is the smallest to the largest. Okay, and when we're talking about in a group of numbers, so if you take the largest number and the smallest number, we did this on the Carnegie where you had to figure out what you were putting down on the graph. You always used the largest y, largest x, smallest x. The difference between those two numbers is called a range. Okay. Now, what are we doing? Well, we're sitting here and we're going to find slope, which means you do the y's, y2 minus y1, okay, this being the y coordinate, this being the x coordinate, okay, over x2 minus x1, okay, and the x1 and the y1 and the x2 and the y2 only designate the first point or the first ordered pair and the second ordered pair. That's why they're y sub 1, x sub 1, y sub 1, x sub 2, y sub 2. Okay, and this is our simple differences. Remember, we talked about that in the previous chapter. So when you subtract these, you end up with 15 over 10. And of course, you always have to reduce your fraction. Okay, and when you reduce your fraction, you end up with, correct, 3/2. Okay, because 5 comes out of both of those. So that means this has a slope of 3/2. So now we have to write this equation in what we call point slope form. Why? Because I can choose either one of these points and I must use the slope. Okay. Now you're given these equations, so you don't have to memorize them. Y minus y1 equals m times x minus x1. And you have this on your reference sheet that everybody should have copied from online. Okay. And then you simply put in the point. It doesn't matter which one you put in. It will not make a difference as long as you put in both numbers from one point or both numbers from the other point. So here you'd have y minus 10. And the reason it's minus 10 is because that minus is in the problem. This 10 is positive, but it's y minus 10. If this 10 was negative, then this would be y, correct, plus 10. Okay, equals, and we have 3/2. And then we do x minus 5. And this is called a linear equation. That linear equation then can get changed. We change it into, this is point slope form. We can change it into y equals mx plus b form. Or we can change it into what they call standard form, which is what we're going to talk about a little bit later in 3.2, which is ax plus by equals c. These are forms of an equation. Just like you have numbers that are written as fractions, decimals, and percentages, they all look differently because they're written differently, but they're the same value, like 1/2, 1/2, and 50%. They all mean the same thing, they're just written differently. Well, that's what we're doing here. All these equations will mean the same thing, we're just transforming them from this equation to this one. So you would distribute, okay, and most of us remember this, y minus 10 equals 3/2 x minus, and then it would be 15/2, because when you multiply, it's just the top number, okay, and then you'd have to add 10 to both sides, and that's the part that's actually a little goofy, because you'd have to change this, instead of 10 over 1, you'd have to make the bottom a 2, which means you have to make this 20. So now when I bring it over here, I'm actually adding 20 over 2. When you add 20 over 2, it's 20 and minus 15, which is 5. So you end up with y equals 3/2 x plus 5/2. And this now is the equation of a line in slope-intercept. So all of these equations all represent the same line. This one here, they're two different ways, but these are the same line. Okay? And if we want to change it into standard form, it's very easy to do so. There's two rules we have to make sure that happen. First, your x and y have to be in that order. Okay, the x has to come before the y, like your first name and last name. Okay, just like when we plot a point, x comes before y. That's why it's called an ordered pair, because it's in alphabetical order. Okay, and then you can't have any fractions in the A or B term or C. It has to be all whole numbers. So what was the way we learned to get rid of fractions? So here is our problem. And who remembers the way we get rid of fractions? Correct. You can get rid of a fraction by multiplying the whole problem by the denominator. So I multiply all these things by 2, and it gets rid of my fractions. So this becomes 2y. These, when you multiply by 2 and divide by 2, they cancel each other out, so it's 3x. Multiply by 2, divide by 2, plus 5. Okay? And now I need to move this 3 over. And it becomes negative 3x plus 2y equals 5. All right. Now, the last part of information that deals with standard form. And this is the thing that gets most people, is that when we're writing something in standard form, excuse me, we want to make sure that 9 times out of 10, this also is not negative. So we have no fractions, and the leading coefficient which means the one in front of the x, the leading coefficient, should be positive. Okay, so simple rule. If I change this sign, what do I got to do to all of them? Correct, change them all. So this becomes 3x minus 2y equals negative 5. All right, so we've briefly gone over in one problem how to find slope for our line of best fit, put it in point slope form, change it to slope intercept form, change it to standard form. But all three of these are the same line. Even these two are the same line. It's just written differently. Okay? You follow some rules. You pay attention to the details. It's not changing the actual numbers. It's not really changing where the line is. It's just changing how you present the line. So, we're going to be dealing with problems where we have slope-intercept form, how we write it in point-slope form, how we change things around, how we move things in a problem, okay, and being able to present it in different facets. Like I said, though, 3.1 is very basic. It deals with vocab, linear regression, line of best fit, the equation of line of best fit, which would be this equation, okay, the equation of line of best fit. And most of the stuff that they want us to do in this first section is done on a graphing calculator, which we don't use. So we're just trying to make sure that we understand the concept behind it. If you understand that there is a line of best fit and that we're dealing with something that is not in a pattern and we're trying to make it a pattern, that's what a linear regression is. Okay, we're trying to figure out if we can estimate, make a good estimate on something that is very hard to estimate. So where do they use this? Well, we use it when we're trying to figure out stock market, money, linear regression. Sales, they try to figure out, okay, well, we take last year, then that the year before that, and they look at all the information for different months, and they go, okay, well, we're going to predict we need this many people working because we're going to have this many people buying stuff. Please don't think that big businesses like retail just magically go, oh, well, we need 5 people working at the register. No. They look at previous sales, they look at previous patterns, and granted that none of them will move in a consistent line, they try to make a line of best fit so they can predict what's going to happen. So if there's a steady increase, they know that they're going to need a certain amount of people to help a certain amount of people in the stores. All right, and it's the same thing they use in restaurant industry. It's the same thing they use in service industry. This is a very popular and commonly used tool, even your weather forecasters, and that's what your book uses, temperature, in order to see and regulate and estimate what temperatures are going to be in the future. Right? So that is 3.1 and a brief overview of what 3.2 is, to be able to change something from one equation to another. And we'll go through several examples in class of both of these things. All right? Have a good night, and thank you for listening.